What's happening, my friends? Austin here with Devve, and again, it is my great pleasure to be sitting down with Tom Anderson, the creator of the DevvX chain. Tom, thanks again for sitting down with us for another Tech Talks. How you doing, man?
Hey, Austin, good to see you. Always great chatting with you.
Good to be seen. Absolutely. So today I want to dive into a topic that I know is on the minds of our community. It's something that is talked about a lot, and I do my best to talk about it intelligently, but like most things in my life, I speak more intelligently than I actually have knowledge of. And so today what I'm hoping we can dive into is the sharding that is present on DevvX, which is admittedly so unique that basically nobody really thought to do it, except you. And so I'm really excited because I know this plays such a pivotal role in almost every facet of the Devve ecosystem. And so I'm really excited to learn about this. So do you think we could start just kind of on an overview, like of what is sharding before we get into the mechanics of it?
Yeah, sounds good. So the term sharding, just at a high level, kind of refers to parallelization of processing on a blockchain. And there's lots of sharding solutions out there. Ethereum had a big push with sharding, maybe pulled back from it a bit. And there's lots of ways that one can try to parallelize, the processing. But when you've got one kind of monolithic blockchain, and then you have validators that are adding blocks to that blockchain, and you try to parallelize their efforts, that's really hard. That's a really difficult way to implement sharding. That's, for example, what Ethereum is trying to do. And that hasn't really got it working. And I kind of think, almost never will. Like it's the desire to have decentralized governance, and anybody can come in and run a blockchain, along with wanting to parallelize that type of processing. That's maybe an unsolvable problem. And so we took a different approach altogether. We, from the very beginning, said, what if you had different blockchains that all kind of interacted and correlated, and you could track what's also evolved into is each application then gets its own blockchain. And so what if you then can have the blockchain tracking data for a particular use case or whatever, has its own validators. And then the way we implement our sharding then is each of those different blockchains we call a shard. And we figured out a really pretty clever way to have blocks go from one shard to another. And so in general, it's just a different approach than anything else out there.
And so when you say parallelization, wow, that is not an easy word. That's like anonymity. I can't say it. Parallelization. When you say that, and is that, the ability to process transactions in parallel with one another as opposed to transaction ordering, or how exactly? I know that there's more to it than that, but what exactly does that entail?
Yeah, so in our case, what it means is just running independent blockchains independently. So in our case, it's pretty simple, right? So if you have a game that's tracking its assets on a blockchain, it gets its own shard and it's processing everything, adding blocks to the blockchain through decentralized consensus, and that blockchain is running. And then we've got another blockchain that is maybe tracking ESG assets, for example. And so that type of parallelization is dirt simple, right? Different applications and different validators are running different blockchains. So that's really easy. So then you run into the problem. Well, what happens if one of those applications starts to need more throughput than a single, shard, single set of the blocks being added to the blockchain can manage? So the thing that we figured out that's clever, really our secret sauce, and this is really what sets Devio's technology and the DevvX blockchain apart from everything else in the blockchain space, is we created a cross shard mechanism where transactions can go from one shard to another shard. So if you have one application like that game, let's say it explodes, starts to get millions of daily active users, has too much throughput for one shard to handle, what we do is we create another shard. And then that shard can be processing in parallel. And if one shard can handle 1,000 transactions per second, a second shard can handle another 1,000 transactions per second. So two can handle 2,000 transactions per second. And if you have 1,000, you can handle 1,000,000 transactions per second, right? And you just keep adding shards as much as you need to scale and that's, again, should be intuitively obvious that that's an easy way to scale, with one exception. what happens when a transaction needs to go from one of those shards to the other shard. So that's our cross shard mechanism. We call our shards T2 networks, and then we call the cross shard mechanism the T1 network. And so what happens then is a transaction flows from the T2 network down to the T1. And I can explain more details on that in a minute. But then the settlement side then flows back to the recipient in a different T2 network. And so if one application has more throughput that's needed or other kind of requirements that are needed, and then we just add shards as the application requires, and then have the cross shard mechanism for that application using a T1 network. So it's a pretty clever approach overall.
Very clever. And so I remember when we were discussing some of this on one of our last videos, and I had a question pop up between now and then in regards to this specifically. And I think I know the answer, but I want to hear what you have to say. So let's say you've got shards that are regulatory compliant for some reason. Let's say they're storing medical data and you've got multiple shards that need to talk to one another. Let's say they're HIPAA compliant, for example. If data needs to pass from a T2 through the T1 to another T2, and there has to be compliance in both of the shards, how is it that the T1 is able to pass that data and remain in compliance?
No, that's a good question. So let's say, okay, so HIPAA is a good example, HIPAA compliance. So let's say you had to have multiple shards running and maintaining medical data. And one of the other kind of really compelling aspects that we found over time, this kind of evolved, is that each shard can be customized not just to an application, but any other kind of need. So you can customize shards to regulatory requirements. So again, this is a good example for that. So you could have a different shard maintaining people's medical data in every state in the US. So you could have 50 shards, right? And then each state can have its own rules about how medical data is managed. Each state can have rules about how medical data is transferred. And so you could have smart contracts that, you could have a specific smart contract that transfers how data leaves California, for example, because they a lot of times have kind of the higher end, requirements. And then what you could do is have a T1 network that is specific to that medical data. And that T1 network would manage just those 50 shards. So you can have multiple T1 networks as well.
Along those same lines, and also the T1. So obviously, okay, so that was a portion I did not know, that you could, kind of had multiple T1s. I was thinking there was just kind of one super highway, but you had mentioned before that the T1 is not a master record of data, similar to like how Ethereum is for layer 2s, right? So it's not actually storing anything necessarily, is it? Am I correct?
Well, it is a blockchain itself, the T1 network, and it runs through our, proof of validation. It's a decentralized consensus algorithm. And so there's multiple validators that keep track of the how the blocks are added. So I'll dive just a little bit deeper into it. So the way that the sharding works is, let's say you have Alice wants to send Bob a transaction, a medical record or a game item or cryptocurrency or whatever, right? So let's say Alice's wallet, so her public address, her public private key pair is on one T2 network. And then Bob, his public address is on a different T2 network. So what happens is Alice's shard processes the sending side of the transaction, and then flags that it's a asset that needs to go to another T2 network. So then it sends an entire collection of data, a block. It's not a blockchain block, but a collection of data that then goes down to the T1 network and says, these are all the transactions that are going to another T2 network. And so then the T1 network then processes that through decentralized consensus as well, and multiple validators, and they have to have whatever percentage is defined. So you could say more than 50% of the validators have to agree, right? So you get Byzantine fault tolerance. And then once that block goes onto the T1 network's blockchain, that the T1 network's blockchain is collecting data and maintaining a blockchain. So what that blockchain is a record of all the transactions that go between shards. So then that transaction that Alice was sending to Bob goes into one of the blocks on the T1 network's blockchain. And then Bob's shard reads that block coming out of the T1 network, says, okay, here's a transaction for one of my users, goes through its consensus, and then handles the settlement side or the receiving side of that transaction. So that's a little bit more detail about how it works.
I've never been so excited to hear technical details of something in my entire life. So, all right. And that is a very elegant way of explaining it. And I appreciate you putting it that way. So, another question that I had for you on the sharding specifically. So, this hasn't been released yet, but if anyone sees this first, you'll know it's coming. I shot a video on quantum resistance the other day, which was so elegantly scripted out by Steve. And we spoke about upgrading the algo on a specific shard. Like if we switch to, I think it was 384-bit encryption as opposed to 256, that it's upgradable in that way. Could you explain a little bit how that's customizable?
Yeah. So in general, quantum computing represents, I guess you'd call it an attack vector on current types of cryptography. And so quantum computers might be able to break, kind of current cryptography that blockchains rely on, including Bitcoin, right? And so we knew that when we were first designing the blockchain, we knew that that was a potential upcoming problem. But the algorithms weren't established and sophisticated enough yet to really and it's also a lot more expensive and so costly to get all this implemented, both in terms of R&D and development and implementation and then productization, all that, and then also processing. So you don't need it yet because quantum computers haven't gotten to that point yet that anyone knows, at least. And so what we did is we built our encryption technologies as basically a module that can be replaced easily. So and this is another thing that's nice about kind of the sharding solution is, you could take each application and modify things as you need for that application. And so if a company is maintaining their ESG data again, or again, a game company is maintaining their games, they can decide at what point they feel like they need to get what algorithms, doing the signing, for transactions. So we designed from the beginning that we could swap out a quantum resistant encryption technology, into each shard.
And so am I right to assume that the actual throughput of an individual shard is going to be somewhat dependent upon the other features that are implemented on it, like, the validator set or the level of security that it needs or things of that nature will actually affect the throughput of each shard?
Yeah. Yep. So each shard is customized to an application. So, if you're running a video game, that's very different than a defense industry application, right? And you might want to have it be something that is very resistant to attackers, very resistant to denial of service attacks. You might have applications that have much more significant memory requirements. You can have applications that really are focused on speed and time of when a block actually becomes, when a transaction goes in, the block becomes finalized to the time of finalization. So any application has its own kind of requirements and needs and specific design criteria. And so yeah, we design each shard to work for that application, and those requirements a lot of times are dials between, you trade off between cost and expense, or speed and expense, or speed and cost, that type of thing. So all of those are set up in the shards. And again, that's if you take a step back, I describe the sharding as what sets us apart from everything else in the blockchain space. The ability to create a particular blockchain for a particular application. I think, like 10 years from now, everyone's going to be like, duh, that's like the only way to do it. It's going to be such an obvious thing versus these, monolithic types of approaches where every application runs on the same blockchain. Like it should be just intuitive that when you have an application, every application has its own requirements. If you can design to those requirements, ultimately that by definition almost is going to be a better solution. It's like using, Microsoft Excel to run a Fortune 500 business. Like you could, but it's a really bad way to do it. Instead, big businesses are run on SQL databases because SQL databases can be customized to what's needed to run that business, versus Excel is like one, kind of, fits everything type of approach. And so blockchain is similar, in that analogy, right? We create shards or specific blockchains that are specific to particular types of applications. It's just such a better way to implement things, and it solves problems that just other blockchains can't.
Well, and the interesting thing, as you're kind of describing this, like you and I both know, there are other chains that have horizontal scaling in that way, like, and I won't mention any names, but they have subnets and different ways of going about it, but there's a certain, A, there's not the connectivity that we have with Devve, but B, there's a certain clunkiness to it. I mean, there is an absolute necessity to switch RPC servers, or to, you have to be you're living on that chain basically, unless a bridge exists or something of that nature, which you have to go through. So to hear kind of the elegant way in which you describe it, it in my mind, and correct me if you feel differently, but in my mind, people throw this mass adoption word around all the time, and I kind of like shiver and cringe a little bit, because I know they're thinking about Starbucks giving NFTs to their customers, and they're not actually thinking about the people that are going to use it, but they don't have a clue that they're using it. And that's kind of what this sounds like to me.
Yeah. I think of our business kind of like Oracle, just, a business that's under the hood. People don't really know what's going on, but powers a lot of what we all do. And blockchains that weren't designed with this approach from the beginning, you can't buckle it on afterwards, right? And people try, and it's just an inelegant, unscalable, expensive in various ways, cost or throughput or whatever, way to implement things. You could implement with side chains, but I've spoken with companies that have taken sidechain approaches to their max, right? And there's a point where once you get to 1,000 or 1,500 or 2,000 side chains, the whole system breaks down, but ours doesn't, right? And you just run into kind of limits of physics that, I'll say math, that you just can't take those approaches. And layer two solutions, ultimately, you're settling on, one monolithic, blockchain. And again, it's unneeded, right? You don't need the transactions from CryptoKitties going on at the same time on the same blockchain as the transactions that are managing nuclear weapons, right? It's not needed. Those transactions never need to touch each other. So why build all the complexity of having the same validators be able to, look at those two different things? And then when you do need transactions to go between different, blockchains, let's say a defense, application where you're managing, weapons, but then, you're also managing logistics and movements, which can include those weapons. Well, then you can have transactions that do need to go between those two blockchains. And then we have our T1 network that very efficiently scales things. We often say that we can process 8 million transactions per second. That number, what that really means, what that number is coming from, is in the early days, we tested our T1 network, and we tested how much throughput the T1 network could process itself. And so when we say we could do 8 million transactions per second, what we're really saying is we could do 8 million cross shard transactions per second. And most applications don't need very many cross shard transactions per second. And so really, you never will have an application that needs that many cross shard transactions per second. And you can scale the T2 networks as big as you need otherwise. So really, we're infinitely scalable for all, practical purposes.
I love that. So, all right, to wrap it up, I hope you don't mind me asking you to share this story, but when Ray was doing my intake interview, he shared a story, and I won't tell too much of it. I'll let you do it, but he shared a story where it was back in 2018 when you kind of had a eureka moment about the sharding, and you called him and you said, "I've got the solution." Would you mind just giving me like 5 minutes of what that was?
Yeah, we had been looking at algorithms. So I was one of the things I think that was kind of interesting about Devve's approach versus what most of the blockchain space has done, because we started in 2016, even started kind of looking at 2015-ish, so early, not as early as Bitcoin 2009, 2010, 2011, but, Ethereum kind of spun up in 2015. So we were in the early days. And we saw, or I saw, a need for blockchain to run kind of with real world business use. And one of the things that's kind of, again, evolved over time is as each year has kind of gone by, all of these early decisions as the industry has matured have been really good design decisions. And I literally, I was mocked in the early days. Like, why are you building an enterprise blockchain? We had an early trade show, I think it's 2018. And we had real big on our sign, the enterprise blockchain, right? And people were like, why are you doing enterprise blockchain? Do an ICO, right? And then it's like, why are you doing enterprise blockchain? Do DeFi. And then why are you doing enterprise blockchain? Do, GameFi, and then do a meme token, right? So I was literally mocked over the years, like, why are you doing that? From people in the space. And so from the very beginning, we kind of said, how can you use blockchain for kind of real world applications? You need scalability, privacy, fraud, theft, and loss, stability, like all the things that real businesses rely on, to run their operations. And so one of the big challenges that we ran into, to answer your question, was scalability. And so we started early on thinking about fraud, theft, and loss protections and privacy solutions and things like that. We kind of very early were looking at stable coins. I actually remember I had one night where I felt like, oh, this eureka moment. And then, if you could take an actual dollar and underlie it, have it underlying a token, and then you Google it and like, oh, that already exists. Tether's done it, right? But again, if you're going to work with real world businesses, you have to ultimately tie into fiat, that type of thing. And so we were looking at all these things, and probably the biggest problem that we didn't have a solution for was the scalability. And this is before we had come up with the sharding solution. And so the idea was, this idea of you have one shard can handle 1,000 transactions per second, another shard can handle 2,000 transactions per second, scale horizontally as big as you ever need. Then you need that cross shard mechanism. And so the eureka moment was I was driving on I-25 here in Albuquerque. And I thought, what if we just had them completely parallel? You could scale as big as you ever need. They don't interact. And then you come up with a mechanism that makes a transaction go, between the shards. And there is no master record. It just is a cross shard mechanism, And then you think, well, like that's not going to work because, if you take it from a blockchain over to a non-blockchain solution or some other type of database, like you're kind of losing the thing you need. You need a immutable, auditable record of everything that happens. Oh, well, what if that cross shard mechanism was a blockchain too? Oh, and then you could just transfer just the blocks and have that T1 network sign entire chunks of data blocks instead of just transactions, right? And so a lot of the details evolved over time, but that basic premise of scale horizontally, have another separate blockchain that only handles the cross shard transactions. And we even at the time were thinking of it as kind of like a weave, where like all the T2 networks are feeding this weave in, and then you think like, well, but you still don't want a master record. You don't, because that creates that bottleneck that you're trying to avoid, the real problem. So what if that just ends up being just cross-shard transactions, right? And it's not a master record, and the T2 networks are the master record. I think that could work. So and I'm even getting a little bit chills now thinking back to it, right? And so I literally was driving on I-25, pulled over on the road, called Ray. I think he was in a different time zone, so it was late for him or whatever. I was like, hey, I think there's a good solution to this scale problem that we've been running into. And so Ray and I talked about it and just had a good conversation. It was just a fun moment in our overall history. So,
well, I mean, the remarkable thing here is not only that it worked, but you came up with that solution before we even had any ETH alternative chains. Everything was still happening on Ethereum. Like we didn't even have DeFi yet. Like it didn't. We had nothing in the industry, and you're coming up with, like, I remember when Polygon came out, and everyone was like, "Oh my god, it's so fast, it's so cheap, life's so good," and then NFTs dropped and it jammed up again. And you came up with this type of a solution back then. I'm absolutely mind blown, Tom. Thank you so much for being here. That was an explanation of sharding that it was better than I could have hoped for, man. I really, really appreciate you taking the time.
So thanks, Austin. Appreciate it.